Hello everyone, my name is Shambhavi and today we are going to solve another question for the statistics which we are just following from last 2-3 weeks, right? So from the last 2-3 weeks we are solving the questions on basically the topics which I have already covered for the statistics videos, right? So today I am present with another good question for you all. Okay. So the question says that on an average a certain computer parts last 10 years. The length of time the computer parts last is exponentially distributed. Find what it is asking. It is saying that problem 1, problem 2, problem 3 and 4. So basically my question is that on an average a certain computer part lasts 10 years, right? So this 10 years it is important, which is like just I have written here. Next, what is it? The length of time the computer parts last is exponentially distributed. Okay, fine, I just understood that thing. Now what's the problems which we are having? So we have four subparts for this question. The problem one is saying that what is the probability that a computer parts last more than 7 years. What we need to do is that we need to quickly find out the probability that the computer part last like more than 7 years. Fine. Okay, so what to I have already solved this type of problem many a times in my videos, even in the question series and even in the video itself. I have solved these type of problems, right? Now today I am going to solve these kinds of questions one more time for you all. Okay, let's get started with the answer for the thing. So problem one. Okay, what is the probability that a computer parts last more than 7 years? Now what it is asking me to say, finding asking me to find. So before that, what I would just find, let me just erase that thing. Before that, I would just write a common thing. So here from the question, what it is got, let x is equal to the amount of, let x is equal to the amount of time a computer part, okay, now I'm just moving down, okay, a computer part lasts, okay, last. So from I just taken a variable that is x and I just given it let x is equal to the amount of time a computer part lasts, right? So this is the normal thing which we basically do, and so I have done that thing here. I have just taken a variable and given it a let's say x is the amount of time a computer part lasts, fine. Now what else was given to me in the question? So in the question I was having something on an average a certain computer part lasts 10 years. So last 10 years, that is the mu for me. So mu was represented by means. Okay, just let me write that. So let me represent that. So mu. So it is equal to 10, right? So from here, what can I just get? So m is equal to 1 upon mu. Fine. So it is this is the formula which you basically use. So I would just write 1 upon 10. So here I would just get the output as 0.1. Fine. So this is done. So this was basically the calculating for the value of m. Fine, this is completed. Now I will just move towards the the problem number 1, which we are having. So my problem number 1, what was it saying to me? It was saying that the computer, what is the probability that a computer parts last more than 7 years? Okay, so I need to find the probability that the amount of time a computer part lasts. So I have just taken it a variable as x. So I need to find that what is the probability that x is greater than 7. Fine. So from here I can just write the problem number 1, that what I need to find. I need to find probability of x is greater than 7, right? Because what was asked in the question. Now read the question very carefully with me one more time. So it is saying that what is the probability that a computer part lasts more than 7 years. I need to find the probability that a computer part lasts last more than 7 years. And for that, what I have taken a variable that is x. So I have given it the amount of time a computer part lasts, right? So this is the probability of finding x is greater than 7. Now what I am going to do here is that I'm going to find out the things. Fine. So I would just write here probability of x is greater than 7. Now what I am going to write here is equal to 1 minus probability of x is less than 7. Yeah, we can do that, right? The probability of x is greater than 7 is equal to 1 minus probability of x is less than 7. Fine. So from here, what I can just write, since probability of x, okay, the capital X, fine. Probability of capital X is my random variable, right? Is less than small x. And now in small x, what I have stored? I have stored the amount of time a computer part lasts, fine. So the probability that random variable of x is like less than x, what I just write here, I will write the formula, that basically the formula which we are going to use, that is 1 minus e to the power minus m into x. Fine, so this is the formula which we basically use for finding the probability, right? Okay, let me not like make it as like this. I would just write 1 minus e to the power minus m into x. Fine. This is dot, that means multiply. Fine. M into x. So this is done. 1 minus e to the power minus m into x. I will just go down. Fine. Now from here, what I can just say, so then probability of x is greater than x is equal to 1 minus, and here I would just put 1 minus e to the power minus mx. Fine. So like what I just changed, I changed the sign, that is from less than to greater than, and I just like wrote 1 minus this side. This is the same thing which I just performed here also. So here I just wrote find the probability of x is greater than 7 is equal to 1, right? So 1 minus probability of x is less than 7. So I just changed the sign and just like put the 1 that. Let me go down. Fine. So here from here, what like I can just write here from like here I can just say that it is, now 1 and 1 would be cancelled. Let me just open that. 1 minus 1, and this would be plus because this minus sign will be multiplied, plus e to the power minus m into x. So from here this 1 and 1 just gets cancelled from me for me. So I just write e minus e to the power minus m into x. From here I just get this thing, e to the power minus m into x, right? Now what I have, I need to find the probability that x is greater than 7, right? I need to find the probability that x is greater than 7. So I would write e to the power minus 0.1. Now just see the difference between this point. So I would just write this point in the downside. This is the decimal one, fine. 0.1, what I have just found, I find the value of m. Okay, so this is the like main reason why I was just finding the value for m, because I need to apply the formula, that is 1 minus e to the power minus mx, and I need to just apply the value for m. The value for m which I just found, that was 0.1. So I just put that value is 0.1 here. And now what is my x? Now x is my 7 this side, because I need to find the probability that it is greater than 7. So now this dot was for decimal, and now this dot which I am just putting here, this, okay. So now that this dot which I am just putting here, this is for finding out the multiplication. So I would just like take it of a different color, fine. So you can just like differentiate between the things easily. So I will just like put it of a little pink color. Okay, fine, little one. Okay, this is not visible, I guess, right? So let me just do the things in a more fine way. Fine. Dot, and now we'll just again take the same color which I was just using. So dot 1 into 7. Fine. So minus 0.1 multiplied by 7. So whenever we just do this thing, the like you can just calculate it in the calculator. Fine. So I would be just getting 0.4966. Fine. So this is the output which I would be getting, and yeah, this is the probability that x is greater than 7. So just let me write that thing here itself in the written. The probability that a computer, and let me go down, the probability that, okay, I just did this side. Okay, I would just now go down. The probability that a computer, what was my like question? The probability that a computer part lasts more than 7 years. Probability that a computer parts last more than 7 years is 0.4966. So this is the probability basically what we have calculated right now, that is 0.4966. Let me quickly like again explain you that what I have done. So I will just take a highlighter for that. Fine. Firstly, what I have found the value for m. So the value for m is found using this thing. M is equal to 1 upon mu. So the value for mu I was already having, that was 10. So I just applied that formula very easily right this side, and I just got the final value for m, that is 0.1. So that I have just calculated. Now what next I have done, I need to find the probability that x is greater than 7. Right, so I just wrote probability that x is greater than 7 is equal to 1 minus probability of x is less than 7. That is absolutely right. Then I just wrote, since probability of capital X is less than x, which is equal to 1 minus e to the power minus mx. So I just calculated all the things. And after calculation, what I just got here, I just got e to the power minus m into x. Find that this was the probability. Now the probability of finding that x is greater than 7. So I would just put the values for m and x which I have already I was already having. So the value for m we have already calculated, that was 0.1, right? And the probability, like the value for x was 7 which we were already having. So I just put that thing. So here I just calculated and got the final output, that is 0.4966, fine. So this is the probability that x is greater than 7. Fine. So this was the first part of my question that I just completed right now. Now moving towards the second part. The problem 1 is completed. So let me do just one thing. Let me just take this color and let me highlight that thing, that the first problem is completed. Fine. Now moving towards the second problem. What we have in the second problem? Second problem, it is asking that on the average, how long would 5 computer parts last if they are used one after another? Okay, so it is asking me to find the average. How long will 5 computer parts last if they are used one after another? Fine, let's quickly solve this thing also. So I would just write problem 2. Okay, so even one more thing, we can just make a graph also for this one. So I would just firstly make the graph here. So these are my x and y axis. So what I would just write, I would just plot my graph. Okay, yeah, it's fine. And here what it is, here it is fx, and yeah, this point is 0.1 which you just calculated the value for m. And yeah, here it is x, fine. So it is 0 and this is 7. So what we needed to find, we needed to find this portion, that x is greater than 7. We need to find a probability that x is greater than 7, right? So we need to just find out this part, and here the mu is equal to 10. Fine. So here like we can just plot a graph also for finding the probability, that we need to just find this probability that x is greater than 7. Fine. This is over. Now let's move towards the problem number 2. So my problem number 2 says me to find the average, right? So now what I would just how will I do that thing? Okay. So what it was saying, on the average, one computer, I would just write full thing, on the average one computer parts, okay, part, not parts. So because like it is one. Part last 10 years. On the average, one computer part lasts 10 years. Therefore, 5 computer parts will, if they are used one after the another, 5 computer parts, and I will just put a comma, if used one after the another, would last on an, and let me again go down, would last on an, on an average. So what I just wrote here, let's quickly see that thing once more. On the average, one computer part lasts 10 years, right? So one computer part is lasting for how much time? That is 10 years. Therefore, so 5 computer parts will last for how much long? This is a very basic question, a very beginner question, even a small child can also do. So that would be 5 into 10, right? So 5 into 10, that is 50 years. So if one computer is lasting for 10 years, 5 computer will last for 5 into 10, and that is 50. So let me write that 50 in a clear handwriting. Otherwise, like I would just get the comment that like what have you written this side? Okay. So here it is 50 years, right? So find 5 into 10, that is equal to 50 years. So this is my answer for the second question. See, now what happens here, basically this statement was looking like very difficult. Okay, I need to find this thing. Okay, how will I do that? But when you just understand the things and do them from a very calm mind, then you can just find out the proper output and the proper answer for whatever the thing you are doing, right? So my question number 1 and my question number 2 are just completed for me right now. Okay, so question number 1 we have just completed, and even the question number 2 we have completed. Now in the second part of this video, we'll be seeing the problem number 4 and problem number 3 and 4. That basically what these like problems are saying, and what we need to just find out in these problems, right? So for today we have found the problem number 1 and 2. So the answers for this is 0.4966 and the second one is 50 years. Fine. Okay. So this is all for this video. Till then, thank you and bye bye.